Imagine an elevator that takes you not between floors, but between Earth and space. Picture yourself at a space elevator terminal, located in a beautiful spot near the equator. As you and other space aficionados enter the elevator cabin, excitement mounts. The doors shut, and your extraordinary journey commences. Gradually, you rise through Earth's atmosphere, observing the awe-inspiring metamorphosis of the scenery beneath you. Earth's curvature is accentuated, and the sky shifts from a vibrant blue to the blackness of outer space. You find yourself amidst the stars, drifting weightlessly in the boundless galactic expanse. Have you heard of the idea of a space elevator? In this video, we will know what a space elevator is. Can we create it? How can it be built? What are its advantages and potential drawbacks? What if we could push the envelope even further and employ space elevators for leisurely trips into space? And where will the potential destinations be? What is a space elevator? Picture this: you enter a building on Earth and step into an elevator that takes you straight into outer space. Sounds fantastical, doesn't it? That's the essence of a space elevator. It's a theoretical transportation system that would link Earth's surface to a specific point in space, enabling us to journey to the space as effortlessly as ascending to the top of a high-rise building. This innovation holds the potential to greatly diminish the costs and environmental consequences of space travel. This remarkable idea was first proposed by Russian scientist Konstantin Tsiolkovsky in 1895, and has since captivated the minds of scientists, engineers, and space aficionados. But can we really construct such an exceptional structure, and what would it entail to turn this futuristic vision into reality? Let's delve deeper. Can we build a space elevator? You might be wondering if constructing a space elevator is feasible. The short answer: not currently, but we're making progress. The primary challenge lies in identifying a suitable material for the tether. It must be exceptionally strong, lightweight, and resistant to the harsh conditions of space. For years, scientists thought carbon nanotubes were the answer. These cylindrical nanostructures, composed of carbon atoms, possess extraordinary tensile strength, ideal for the immense stress a space elevator tether would undergo. However, despite advancements in nanotechnology, we have yet to determine how to produce the lengthy carbon nanotubes required for a space elevator. Nonetheless, don't lose hope. Graphene, a one-atom-thick sheet of carbon atoms, is another promising space elevator material. Stronger than carbon nanotubes and bolstered by recent production breakthroughs, graphene is becoming a more feasible option for large-scale projects like the space elevator. Although we can't commence construction immediately, the prospects for space elevator materials are brighter than ever. How to build a space elevator? Building a space elevator is based on this concept: a lengthy cable, or tether, stretching from Earth's surface into space, with a counterweight at the far end to maintain tension. The cable would be secured to a ground-based station, while the counterweight would be positioned above geostationary orbit, approximately 35,786 kilometers above the Earth's equator. This astounding distance is crucial for the proper functioning of the space elevator. At geostationary orbit, celestial objects travel at the same pace as Earth's rotation, appearing stationary in the sky. Positioning the counterweight at this altitude ensures that the space elevator remains fixed relative to Earth, permitting objects to traverse the tether without being hurled into space. Imagine a rock tied to a spinning string. The rock maintains a constant distance from the center, akin to the space elevator's counterweight. To transport cargo and passengers, we would require a climbing vehicle, often called a climber. The climber would latch onto the tether and utilize electric motors to ascend and descend the cable, smoothly conveying its occupants between Earth and space. It's a genius idea, isn't it? Give us your opinion in the comments. Your opinion matters to us. What are the advantages of this genius idea? Assuming we can address the material challenges, constructing a space elevator offers numerous benefits. Let's examine a few key advantages. 1. Affordable space travel. The potential for significantly reducing space travel costs is a major incentive for building a space elevator. Currently, we rely on rockets for launching satellites, scientific instruments, and even people into orbit. Rocket launches are incredibly costly, primarily due to the vast amount of fuel needed to propel these colossal vehicles through Earth's atmosphere. A space elevator would bypass the need for rocket launches by providing a direct, reusable route to space. Climbers could be powered by Earth-based renewable energy sources, making the process more cost-effective and eco-friendly. Some estimates suggest that a space elevator could slash the cost of transporting payloads to space from around $20,000 per kilogram to just a few $100s per kilogram, an absolute game-changer. 2. Empowering orbital solar power. A fascinating possibility with a space elevator is the capacity for orbital solar energy. By installing solar panels in Earth's orbit, we can collect sunlight around the clock, unobstructed by clouds and Earth's rotation. This energy could be sent back to Earth, offering an almost infinite, environmentally friendly power supply. The significant costs of launching and maintaining solar panels in space are currently a major obstacle to developing orbital solar power. Nonetheless, a space elevator could dramatically reduce these expenses, making it a practical and sustainable energy alternative for the future. 3. Consistent and uninterrupted space access. Relying on rocket launches also makes access to space unpredictable and prone to delays. Adverse weather conditions, technical problems, and other factors can all contribute to launch postponements, hindering our ability to reach space. A space elevator would offer continuous, dependable access to space, enabling us to send cargo and passengers to orbit whenever desired. This would revolutionize space travel, making it more akin to boarding a train or plane rather than embarking on a perilous, one-off mission. 4. Fostering space tourism. With companies like SpaceX and Blue Origin gaining traction, space tourism is gradually becoming a reality. However, the prohibitive costs and inherent risks of rocket launches mean that, for now, space travel is limited to the extremely wealthy and daring. A space elevator could alter this landscape by making space travel more affordable and accessible to the general public. Imagine taking a weekend getaway to a space hotel or even spending your honeymoon on the moon. What are the potential drawbacks and obstacles? Although the space elevator concept is thrilling, it is vital to acknowledge the potential drawbacks and issues associated with constructing such a structure. 1. Political and legal complications. Constructing a space elevator would likely encounter numerous political and legal hurdles. The elevator's base station would need to be situated close to the equator for optimal stability, potentially causing disputes over land rights and territorial claims. In addition, a legal framework governing the structure's use and ownership would need to be developed, possibly involving intricate international negotiations. 2. Construction costs. Constructing a space elevator would be an unparalleled engineering accomplishment, and the project's expenses would be enormous. Estimates range widely, but some predictions place the cost as $10 billion. Acquiring the necessary funding would be a significant obstacle to overcome. 3. Space debris. Another challenge confronting the space elevator is the danger posed by space debris. Space contains numerous debris fragments, from spent rocket stages to non-functional satellites. These objects travel at tremendous speeds, and even a small piece of debris can inflict catastrophic damage to the space elevator's cable. To safeguard the elevator, we would need to develop sophisticated tracking and debris removal systems to protect the cable. This introduces another level of complexity and expense to the project. So, how can we harness space elevators for recreational use? The idea is straightforward: build space elevators outfitted with passenger cabins, and create a one-of-a-kind transportation method that carries tourists on an astonishing voyage beyond our atmosphere. Where might these space elevators transport us for leisure? The options are limitless. Here are several potential destinations. Space stations. Visitors could tour research stations and other installations orbiting our planet, offering an up-close look at the state-of-the-art technologies and experiments shaping our destiny. Orbital hotels, extravagant hotels in low Earth orbit could provide guests with an unparalleled experience, featuring zero-gravity facilities and breathtaking views of Earth from space. Asteroid mining bases. As asteroid mining becomes increasingly common, tourists could head to these distant bases to discover more about this burgeoning industry and its part in space colonization. Lunar expeditions. Over time, space elevators could enable journeys to the Moon, permitting travelers to investigate its captivating landscapes and observe Earthrise from our natural satellite. In conclusion, the space elevator is a captivating idea with the potential to transform space exploration and unlock countless opportunities for scientific advancements, economic development, and even tourism. While the challenges of building such a structure are considerable, the potential benefits are too substantial to disregard. As materials science and engineering progress, the vision of a space elevator could become a reality. When that day arrives, we will be prepared for an exciting voyage from Earth to the cosmos. Do not forget to subscribe to the channel, publish it, and press the like button, as this helps us a lot in publishing more wonderful inventions and more technology. Thank you for joining us on this journey.